Hello, my name is Andrew Feldman with NanoSemi. Today I'm introducing MyDPD, the new complete system for evaluating NanoSemi's wideband linearization against a custom PA and signal chain for PA output power up to 100 watts and LTE carrier configurations up to 100 megahertz instantaneous bandwidth. MyDPD is a system that drops into the user signal chain to enable the testing of a wide range of PAs with linearization. NanoSemi's wideband linearizer has been verified against Doherty and Class AB PAs implemented in gallium nitride, LDMOS, gallium arsenide, and CMOS technologies. The MyDPD evaluation system has an analog devices transceiver and a user-friendly evaluation GUI that provides LTE test waveforms and the ability to configure crest factor reduction and digital pre-distortion in NanoSemi's linearizer. The MyDPD evaluation GUI can configure RF frequency and power to match the intended PA usage scenario. There are 3 MyDPD linearizer parts to choose from, and the best choice is dictated by the PAP out in the usage scenario. NanoSemi's 100-50 wideband linearizer part is the highest power grade offered with MyDPD, supporting up to 50 dBm or 100 watts of PA output power. The 100-43 and 100-36 parts support up to 43 dBm and 36 dBm of PA output power respectively. All linearizers with MyDPD support up to 100 MHz instantaneous bandwidth of LTE signal, and P out equals P3dB minus PAPR. Now I will walk through linearizing a PA using the MyDPD evaluation system. Along the way, I will touch on each component of MyDPD. The assembled signal chain in my test bench includes a 4-watt PA with a preamp driven by the TX on the analog devices transceiver. The PA output goes to a spectrum analyzer, with a couple back to the ORX on the analog devices transceiver. The MyDPD evaluation platform shown includes NanoSemi's linearizer SD card and a Xilinx FPGA which boots NanoSemi's linearizer, as well as the analog devices transceiver with the aforementioned TX and ORX connections going out to the signal chain. The NanoSemi evaluation GUI controls the linearizer and the analog devices transceiver. Initializing the MyDPD evaluation system creates a network connection to the evaluation platform. The user can control RF center frequency, TX output power level, and on-off state for the transceiver. For NanoSemi's linearizer, the user can set the target level for crest factor reduction and activate or deactivate digital pre-distortion. Gauges provide baseband signal level feedback from the TX and ORX. When TX-ORX sync is pressed, NanoSemi's linearizer automatically calibrates delay and complex gain for the signal chain. After TX-ORX sync finishes, the user can choose an LTE test waveform. For more flexibility, the user can go to the Select Waveform drop-down and select LTE Signal Wizard, where they will be brought to the Signal Wizard tab that allows them to select up to 5 LTE carrier waveforms to aggregate. Now let's walk through a test case with NanoSemi wideband linearization. Before initializing the MyDPD evaluation GUI, it is essential to terminate the TX with 50 ohms. Let's initialize the MyDPD evaluation system. And this message is the indication that it is safe to reconnect the PA and signal chain to the transceiver. Now that the signal chain is reconnected to the transceiver, let's continue. Now initialization is finished, so I can use the GUI controls to configure the evaluation system for my PA and signal chain. Let's turn on the TX, which we'll note is initialized to the lowest possible power level. We want the RF center frequency to be 2600 megahertz. That's good. The signal level at the observation receiver is in the green region, which indicates that there is no degradation or minimal degradation due to either noise floor or nonlinearity. All right, now that the evaluation system is configured for the PA and signal chain, let's run TX-ORX sync. The system is configured. Let's choose the first of the default waveform options offered by the GUI, the 5 carrier 20 megahertz, and hit apply. And we can see that in the baseband preview windows, we get a spectrum plot and an AM-AM plot corresponding to the PA output as seen at the observation receiver. You can also see right now on the spectrum analyzer as well the PA output. Now to linearize the PA, all we have to do is switch on adaptation. We can immediately see on the spectrum analyzer the improvement in the signal quality, in other words, the lowering of the ACPR. And we can also see this in the baseband in the GUI. That's the before and after shot, and then we can get the same thing for the AM-AM plot. So these two plots are showing the observation receiver signal before and after DPD. Great. So we've shown that we could linearize the PA with a 20 megahertz 5 carrier waveform. This time, let's design a custom LTE test waveform using the signal wizard. You can see the preview of how the waveform will look. Now I've built the waveform, so let's see if we can upload and linearize the PA with this waveform. Now that we're done in the signal wizard, we return to the DPD CFR tab, and with LTE signal wizard still selected, press apply waveform. Now, let's turn on the linearizer. And again, looking at the spectrum analyzer, we immediately see an improvement, which is reflected in the baseband spectrum and AM-AM plots. So, we have demonstrated linearization for both the default LTE waveform included in the MyDPD evaluation GUI and also a custom LTE signal wizard waveform. Let's recap. Today I introduced MyDPD, the new complete system for evaluating nanosemi's wideband linearization against a custom PA and signal chain. I walked through the process of linearizing a PA using nanosemi's user-friendly evaluation GUI. You can visit www.nanosemitech.com and go to the Evaluation tab for more information or if you would like to place an order. Thanks for watching.